Hello, everybody, and welcome to this edition of Science Show and Share. We're so excited to have you joining us. Sorry. One moment. Sorry, everybody. Just one moment, please. All right. Thank you, everybody, for joining this edition of Science Show and Share. I'm here today with Series Education and Outreach, and we've got Russ Schumacher from Colorado, from the state of Colorado. He's a state climatologist and also is a professor at CSU. Today, we're going to be talking about drought, climate, and climate change in the Southwest. Thank you, everybody, so much for joining us. We're really excited to have you here. I'm going to let Russ introduce himself in just a moment and speak more about the work that he does here in the state of Colorado around drought and climate. Our program for today is going to include this short introduction, and then we'll jump right into our talk here. It'll be followed by a Kahoot question, so all classrooms will get to join and answer some of these questions on Kahoot. And finally, we'll have a live Q&A at the end where everybody will be able to ask their questions directly to Russ. And finally, we're going to raffle off a rain gauge. So everybody who's joining us today, if you registered, you'll be entered in the raffle. And we're really excited to be able to send that out to some of the classrooms joining us today. A little bit about Series Education and Outreach. Series stands for the Cooperative Institute for Research in Environmental Sciences. We are based out of the University of Colorado at Boulder, and the cooperative part here stands for the relationship we have with NOAA, the National Oceanic Atmospheric Association, who manages a lot of the climate monitoring for the United States. So we're really excited to connect some of this science to you in the classroom, to the public. And with that, I'm going to jump to Russ.
All right. Okay, there we are. Can you see it okay, Daniela? I hope so. I hope we're looking good. Let me flip back. Yeah.
Yeah, we look good now, Russ. Thank you so much. Looking good.
All right. Good. Well, yeah, great to be here with everybody this morning. Thanks for joining in. I'm gonna talk to you a bit about climate and drought and how climate change is affecting those in the Southwestern US. My name is Russ Schumacher. I serve as the state climatologist for Colorado. And something that people ask me quite often, kind of before we get into the actual content here, is what's a state climatologist? What does a state climatologist do? And so our office here in Colorado is called the Colorado Climate Center. We're actually based at the university, at Colorado State University in Fort Collins. And so what we do in the state climatologist's office here is three different kind of main areas. So one is climate monitoring, keeping track of what's happening around the state and how it's affecting people. So this involves collecting some of our own data and analyzing other types of weather and climate data that's out there. And I'll show some examples of that as we go through. Climate research, so topics related that are important for Colorado, like drought and snow and floods and high impact weather events, trying to understand those and put them into context. And then climate services, so that includes archiving data, analyzing data, providing expertise and context to people who are interested in these topics. That includes presentations like this to school groups or to the media or to other organizations, and we do a lot of that. And here's a picture of our team here at the office. So it's a great group of folks to work with. All right, so to start out with, I always like to show this. a focus of a map of Colorado. So this actually is not a climate map, but it's a very important map if we're thinking about our climate. And this is the map of the topography or the terrain in Colorado. And the color scale here is one I came up with that I kind of like, that's based on the colors in the Colorado state flag. And so we can see the huge variations that we have across Colorado. So if you go to eastern Colorado, we have the river valleys. So you can kind of even pick out here the low elevations of the river valleys, like the South Platte River or the Arkansas River in southeastern Colorado. And then, of course, what Colorado is famous for is our mountains, right? So you can even pick out some individual mountains here. This is Pikes Peak in this area, the Front Range, the San Juan Mountains in the southwest, and then lots of variations in western Colorado. So the river valleys, the Colorado River, the Gunnison River, and then we see other interesting features like the San Luis Valley in southern Colorado, which is a high elevation desert, essentially. And so you kind of see this map of the terrain, and we see all the different variations that we have around the state. So Colorado is on average the highest elevation state in the United States. And right, just a lot of different things to take a look at here. And then if we switch this to a map of the annual average precipitation, you can see that if we go back and forth between them, there's a lot of similarities, right? The mountains are probably the number one thing that determines the climate of that particular location. And so we can see we have everything from the very, very dry conditions in the San Luis Valley in southern Colorado that only gets maybe 7 or 8 inches of precipitation per year on average, all the way up to the very, very snowy locations, like, for example, the Park Range in northern Colorado that gets over 50 inches a year of precipitation. And that comes in the form of hundreds of inches of snow, 300 or 400 or 500 inches of snow each winter, and kind of everything in between. So it's a complicated place to study the climate, but also a super interesting place to study the climate because there's so many different, really so many different climates that we have. And some of those can be very close to each other, where just over the span of, 30 or 50 miles, you can go from high snowy mountains to really dry areas in a short distance. So we kind of look at that in terms of where the precipitation falls. And then it's good to think about what can happen to a raindrop or a snowflake after it falls. Take a second to think about all the different things that might happen to that little bit of water, whether it's rain or snow or even hail after it falls. So what might happen to that water? So if it rains, that water might soak into the soil, right, and kind of moisten up the soil. It could evaporate right back into the air, right? You might have seen situations where you can see the rain falling out of the cloud, but it's actually not making it to the ground. So it might evaporate back into water vapor before it even reaches the ground. If it accumulates on the ground, it might run into a stream or a river, and that's the source of the water that we all use in a lot of different ways. It might be used by plants to grow. If that water falls and into your garden or into a farm field, right, the plants are going to use that water because they need water to be able to grow. If it's snow in the winter, it might build up the snowpack in the mountains, and we'll talk more about snowpack because it's a really important thing here in a minute. Or maybe at the end of all of this, or if it's snow that falls, it might go directly from snow to water vapor. This is a process called sublimation. That is another thing that can happen to snow or ice, and it goes directly from snow or ice to water vapor. And then at the end of all of that, right, what might we do with water? We might drink it, right? We need water to live as people. Animals need water to live, and that might be the end result of the rain and the snow. And all of these things are part of the water cycle. So you've surely heard about the water cycle or the hydrologic cycle. All of this is part of that water cycle: the precipitation, the clouds, the rivers, the oceans, the evaporation into the air, are all key parts of that water cycle. So specifically here in the Western United States, what's really key is to the water cycle is the buildup of snow in the mountains each winter. So this is referred to as the snowpack. And what this graph shows, and I'll let this run through again here to see the animation. So the gray line that you see here is the buildup of the snowpack in the mountains here in Colorado over the course of the winter. So usually in Colorado, at the high elevations, we start getting snow in October. We've had a little bit already. We'll have more coming soon. And then all the way through March or April or even into May, it continues snowing regularly in the mountains. And it's cold up there. And so that snow doesn't melt. And so it stays up there all winter and it just builds up. And so on this graph, we see on the gray here, it's the buildup of that, what says SWE here, SWE, snow water equivalent. That's the water that is stored in that snow. And you can see in a wet year or a snowy year like 2011, it can build up to be a huge amount. And then once we get to the spring and summer, it warms up, the days are longer, the sun's out for longer, that snow starts to melt. And what happens to that snow after it melts? It runs off, some of it goes into the soil to recharge the soil moisture, but a lot of it flows down into rivers. And that's what this blue shows here. So this is the melt and then the eventual runoff into a river. So we see the buildup of the snowpack over the winter, and then it pretty rapidly drops off as it warms up in May and June, and then that water runs off into rivers. We can compare that here to just the year after that. 2012 was one of the worst drought years that we've had in Colorado, and there was very little snow in the mountains, and so you can see much less snow in the mountains, and then much less water in the rivers when it runs off in the spring. So this is kind of the cycle that goes from wet years to dry years, or what are referred to as drought years, and the snow can be a big driver of that process. And one other thing to point out is that as that snow builds up in the mountains each winter, especially here in Colorado, we're what's known as a headwaters state. So all these different rivers start in Colorado. So the water that goes into them is really coming from the snowpack in the winter, and that's our natural reservoir of water that gets stored up every winter, that then feeds those rivers that run off. How do we measure snow? So scientists that measure snow, this is a really important thing to keep track of each winter. So there's stations that are automated that are referred to as SNOTEL, or snow telemetry stations. These are stations that are put in these mountain areas. They have measurements of the snow, and actually the key measurement here is sort of interesting. It's a pillow. So it's basically a pillow on the ground, and it weighs how much of the snow is on top of that. And we know how much water weighs, and so you can convert the depth of that snow into how much water is there. And that's that SWE, the snow water equivalent. So people in my business, we spend a lot of time looking at that data in the winter to see how much snow there is up there. But there's also people that go out and make these measurements too, because there's certain places you can't really put these stations, and so people go out and make these measurements and have been doing this for decades, and so you get the amount of snow that way. They have to snowshoe into some area in the mountains and then dig a snow pit and make the measurements of how much snow and how much water there is in that snow. So another concept that you maybe are familiar with, and we looked at the mountains in Colorado earlier, now we look at the mountains across all of North America. And what this red line shows is what's called the continental divide. And so it's the dividing line between where water flows west versus east. So everywhere to the west of this red line, when that snow melts in the mountains and it goes into a river, it's feeding rivers that flow eventually to the west. So if the water falls in western Colorado, it's going to end up in the Colorado River eventually and flow into Mexico, into the Gulf of California, or into the Pacific Ocean. But if it falls east of the Continental Divide, it's going to go into one of these other rivers that then eventually flows into the Gulf of Mexico or into the Atlantic Ocean. And so if you've ever been up to the mountains, like in Rocky Mountain National Park, you can drive across the Continental Divide or even hike across the Continental Divide, and you're crossing that dividing line of where water's flowing west versus east. And in Colorado, there's a big difference in the amount of water that goes west versus east. So this is a map showing the river flows in the different rivers within Colorado. And so you can see the biggest one is the Colorado River that flows west, and we'll show that, an example of that, or a kind of a visualization of that in the minute. So this is sort of an interesting unit here. AFY is acre feet per year. So an acre foot is kind of the unit that's used for water. It's how much water would cover an acre of land a foot deep. So the Colorado River takes 4.5 million acre feet per year out of the state of Colorado. And this is water that serves millions and millions of people throughout the Western United States. Going east, there's the South Platte and the Arkansas rivers, and these have they're still big rivers, but they have much less water flowing through them each year. But in contrast, if you look at the population numbers here, way more people in Colorado live east of the Continental Divide, like 4.5 million, and it's a bigger number than this now. This is sort of an older number. And then, maybe a tenth of that, or a little more than a tenth of that, west of the divide. So we have this kind of divide in water that is in contrast to the divide in people. So a lot more people east, but less water, and a lot more water west, and more water, and less water to the west of the divide. All right, so we're going to take a look now at a visualization that shows what happens to water if it falls in the high elevations of Colorado and flows downstream, eventually into the Colorado River. So this is a super cool tool. You can go on this website and put a dot anywhere in the United States, and it'll show you where that water would flow. What I'm going to show here is what happens to water if it falls on the west side of the Continental Divide near Rocky Mountain National Park. Probably many of you have visited Rocky Mountain National Park. And so I'll start the video going here. So we're going to put the dot there, basically on the west side of the divide in Rocky Mountain National Park. And this is going to show us where that water goes. So here we are at the start. There's Grand Lake and Lake Granby, two big reservoirs in northern Colorado that store water. So a reservoir is a water storage, an artificial lake essentially for storing water. And here we go down the Colorado River through western Colorado, and you can follow along on the map in the upper left. So there was Glenwood Springs. We went through Glenwood Canyon, Glenwood Springs. Maybe some of you have been there. We're going through Garfield County now in western Colorado, and we're going to keep going down the Colorado River here, and we're going to reach here the Grand Junction area, the Grand Valley. So this is where the Gunnison River comes together with the Colorado. They meet, and we go into Utah. Now we're going to just speed it up a little bit for the sake of time. Here we are going through eastern Utah, Canyonlands National Park. Maybe some of you have visited there. This is Lake Powell, the second largest reservoir in the United States. So you can see Lake Powell there. And now we're going to reach a place that you've certainly heard of, and we'll slow it back down again. Where are we now? We're going through the Grand Canyon. We're following the Colorado River through the Grand Canyon, this amazing canyon that's been carved out over millions of years of water flowing in the Colorado River through this landscape. And so here we go through the Grand Canyon in Arizona. And eventually we're going to reach, we're going to come out of the canyon there. We'll speed it up again a little bit here. We're going through, there's Lake Mead, the largest reservoir in the country, which has had water declining in it a lot over recent years. And eventually we reach, we end up in Mexico. So this is the fate of water that falls in the headwaters up in Rocky Mountain National Park in Colorado. And you can see it flowed, into the Colorado River and all the way down to Mexico. So it's quite a journey for water through that area. And as we talked about a few minutes ago, right, not all of that water is going to just go right into the river. Some of it's going to be used for drinking water, for growing crops, for storing for future dry years. But that, you know, that's the path that water would take if it was allowed to go all the way through. But one other exception to that is that people have developed systems to take water from one basin and move it to another. So like here in the Front Range in northern Colorado, east of the Continental Divide, there's a series of pipes and tunnels that bring water from the west to the east, where the majority of people are, and we use it in this area for agriculture, for drinking water, for things like that. Okay, so the issue that's coming up in this big basin, the Colorado River Basin, is that the amount of water in that river has been declining over the last 20 or 25 years. So this is the natural flows each year. So one thing you can see in these green bars is they vary a lot from year to year naturally, right? So there's some very wet years, very dry years, depending on how much snow falls in those mountains. But the last 20 years or so, since about 2000, there's been a lot more dry years than wet years, and the river flows have declined. So this orange bar shows the average over kind of the 20th century, and it's about 15 million acre feet flowing in the Colorado River. In the most recent 20 years, it's more like 12 or so million acre feet per year. And there's some very, very dry years in here more recently that the average over that period would be even lower. So this is a big issue because tens of millions of people rely on the water in the Colorado River, and it's been declining. And so one reason for this is drought. So we can think about what drought is, and it's actually not a really easy question to answer. So if you are, look at the media, you might immediately think of drought would be a picture of dry, cracked ground like this, and that's certainly one impact of drought. You might think about impacts to crops. So this is just last year in Colorado in 2022. The influence of drought on a cornfield in eastern Colorado. So there wasn't enough water to grow the corn in that year. You might think of lakes and reservoirs declining. This is Lake Powell. This is a boat ramp that you used to be able to put your boat in the lake at the end of this ramp, but you can see now the water is way down farther than there, so you can't use this anymore. Because the water level has declined. You might think of something like the Dust Bowl that affected the Great Plains of the United States with these big dust storms back in the 1930s. Or you might think of wildfire, like we've had quite a bit of here in Colorado in recent years. This is one of the big wildfires in 2020 here in Colorado. And so these are kind of all different aspects of drought. And this is a quote from a well-known scientist in the field that says, as with rainbows, each person experiences their own drought. If you're a farmer, your experience of drought might be quite different from someone who's affected by a wildfire, but the impacts of drought are still there either way. And there's also different types of drought. So the first thing you might think of is that, well, it didn't rain very much, and that would be referred to as meteorological drought. So the weather patterns are dry, and we're not getting enough rain. So that's kind of where things tend to start. But then the other types of drought start to proceed. So there's what's called hydrological drought. So this is where the water supply gets low. Agricultural drought, like I said, crops start to become affected by drought. Socioeconomic drought. If you are, own a business that is renting out boats on Lake Powell for people to use and recreate in the lake, and the water levels come way down, that's going to affect your business. There's lots of other businesses that would be affected similarly. There's also ecological drought, where, for example, the natural landscape gets affected in a way that animals or plants that are naturally occurring are affected. So there's a lot of different types of drought that have different impacts, and we kind of see those listed here. One way you can keep track of what's happening with drought in the United States is the US Drought Monitor. So this map comes out every week. It's a map that tries to represent drought across the country in a single map, which, as we've seen, is not an easy thing to do because of all the different types. But where you see these really, the red and the dark brown colors, that's where the worst levels of drought are occurring right now. Areas in white are not being affected by drought at the current time, and you see the different categories there. So right now, about 40% of the United States is in some level of drought. Okay, so now let's see how climate change plays into this factor and how the warming of the planet is affecting drought. So this is for Colorado, and what this shows is the temperature going back to the late 1800s. The blue bars show years that are cooler than average. The red bars are years that are warmer than average. What we see is in the last few decades, there's really kind of all years are warmer than average, and this is the influence of climate change, of warming. So here in Colorado, for example, 7 of the 9 warmest years on record have been since 2012. Here locally, this particular year is has not been especially warm, but it's kind of the change in the average that reflects the climate change trend here. And this has been particularly acute in the summer. This is the same graph, but it's for the summer season. And what we see is that the 8 warmest summers in Colorado have been since 2000. So this is where the warming has been, the summer, of course, is naturally the season where it's the warmest, but it's been especially warm in the summers recently. And so why does that matter? Why does the warmth matter? So if it's warmer, if it's windier, if the air is less humid, basically that air is thirstier. You can think of that air being thirstier for water from the soils, from crops, from forests. That is known as evaporative demand. It's the air wanting to pull water out of wherever it can find it. So it would reduce the runoff. It means more of the water from it stresses out crops by taking more water out, and leads to these drought impacts that are kind of separate from the fact that it maybe isn't raining as much as well. So here's a graph that we use to illustrate that. So this is a graph for Colorado. It kind of shows the longer term wet periods and dry periods. And so you can see on this graph, there's wet periods and dry periods that come and go. And we've had, drought is not a new thing. There have always been droughts here, especially in the Western US. So we can see, for example, the 1930s, this was the period known as the Dust Bowl, was extremely dry for many, many years. And similarly, we see some periods kind of like that recently. And so, but focus on the right-hand side of the graph here, since about 2000, I'm now going to add in the effects of that increased evaporative demand, the additional thirst for water from the air, and what influence that ends up having. So if we go from this graph here, which considers only the rain and snow, and then add in the effects of rising temperature, now looks a lot drier. The wet periods don't look as wet, and the dry periods look worse. And that's the effect of climate change on drought, is it's taking dry periods that would naturally occur, lack of precipitation, and making them worse. So making those droughts more intense. And then when we do have a period of above average rain, that water doesn't go as far as it would have in the past. And so a good example of that was the drought of 2020. So in the Southwestern US, it was a record warm summer across a large area. So this is, as an example, the month of August 2020, everywhere you see this dark red color, it was the warmest August on record. And it was also very dry. And so the idea is that it's a hot drought. It's that it being hot and dry is worse than if it's only dry. I'm going to skip that one. But so what we ended up seeing then as part of the impact is the worst wildfire year on record for Colorado. So the 3 largest wildfires that have occurred in state history that we know about all happened in 2020. So the Cameron Peak Fire here, the East Troublesome Fire, and the Pine Gulch Fire, as well as several other very large fires that occurred that year. And here's an animation showing from satellite that East Troublesome Fire in October, right? Just about the same day of the year as we're at right now. So you can kind of see the visualization of where the fire is and then all the smoke streaming away. All of this over here is clouds. So this was like a cool, cloudy day in eastern Colorado, but this wildfire was raging to the west. And so what do we expect to happen to water as the climate continues to warm? So the snowpack in the spring probably will decline, but there's only medium confidence in that change. One thing that will likely change is the runoff. That meltout will happen earlier in the spring because the springs will be warmer, the snow will start to melt out quicker. The evaporative demand will go up because it'll be warmer. That's a very high confidence change in the future. And that means that the soil moisture will probably go down as a result as well. All right, so let's kind of wrap up with some things that you can think about that maybe you can do. And there's a lot of other ones that I won't have time to cover here. But this pie chart shows a typical household's use of water in Colorado. And this green here, as you can see, is outdoor use. So this is basically on average, half of the water that we use in our households is outdoors. So it's watering lawns and gardens and things like that. So that uses a huge amount of water to keep green grass going in a dry place like Colorado. So one thing you and your family could consider is to move to a more water efficient landscape like wildflowers or other native grasses that don't use nearly as much water to keep them going. Another thing you can do to help, you can consider even at your school, for example, is help to measure rain and snow. So this is, we operate this network called the Community Collaborative Rain, Hail, and Snow Network, or COCORAS, kind of a funny acronym. It's our 25th year. There's the website linked there. What this is just people volunteering all around the country and even in other countries now to put a rain gauge in your backyard. We're going to raffle off a rain gauge here a little bit. You can put it at your school. You go out and measure the rain each morning and enter that in. And your dot could be on a map like this, showing all the volunteers around the country, the US, Canada, the Bahamas, Puerto Rico. And your dot could be on this map and show the precipitation you've measured. And it turns out that this is a hugely useful data set. So over 2/3 of the precipitation observations in the United States come from volunteers making those measurements in their backyard. So I'll stop there. There's our website, my email address if you want to reach out. If you're interested, we do monthly webinars on the climate in Colorado. We send out monthly summaries, and you can kind of keep on top of things that way. And I think Daniela will send around this list of links. These are the links to the various resources that I showed if you want to read more and learn more about that. So I will stop there and move on to the next part.
Russ, that was awesome. Thank you so much for sharing all of that information with us. And thanks for everybody for joining us this morning for that talk. So I would love to hear from some folks who are online and with us on YouTube. If you'd like to share in the comments where you're coming from, that would be awesome. If you'd like to get entered into the raffle, since we've got 12 viewers right now, I'm going to ask all 12 of you to just send a comment in the chat, and I'm going to work on the raffle while we answer some Kahoot questions. So hopefully we have some classrooms online. Now, if you and your classroom are with us, definitely share in the chat where you're joining from. We would love to hear from you. I know Mary Richmond has joined us from Fort Collins. She's over at CSU this morning. I'm joining from Boulder, Colorado, from CU here on campus. Randy Russell is joining us from Boulder. Also awesome. Thanks so much for joining us today. And as we go through these Kahoot questions, I'm going to just share my screen here in a moment for some Kahoot questions. Please go ahead and comment, share where you're coming from, share if you've got a classroom, maybe what grade level they are, and I'm going to continue to add folks as you comment into our raffle. It'll be the very last thing we do in this webinar. We have about 15 more minutes where we'll be online, and I'm excited to take questions from folks. So if you have questions for Russ, now's a great time to start adding those into the chat. I see we've got Martha, Ms. Alvarez here with her high school class. She's got 9th to 12th graders. Do you have questions for Russ about some of the content that he just shared? And while you all organize your questions, I'm going to go ahead and share our Kahoot. Let's see here. All right, so we've got a Kahoot. I have 3 questions for you all. I would love to hear from you and your students. Please type the PIN in. You can scan the QR code. Students, if you've got your teachers, I'll kind of leave this up to you, but it would be awesome to have everybody who's interested in joining. You can play on your own. You can play as a classroom. And we'll kind of collect some questions here and wait for players to join in the Kahoot. Cool, I have one person joining so far. We'll let a few people kind of jump in here and join, and then we'll kick off our Kahoot. Also, please continue to share questions in the chat. Russ will be taking questions in just a moment from folks. And awesome. I see some people still trickling into our Kahoot. Maybe we'll answer one question, Russ, while we wait for folks to join the Kahoot here. Mary asked, how much water from the Colorado River is used for agriculture in eastern Colorado?
Yeah, so no, that's a really good question. And I don't have the number handy separating eastern versus western Colorado, but for Colorado as a whole, it's about 10 times as much water is used for agriculture as is used for like municipal and industrial use. So like I showed that pie chart that has 50% of household use is outdoors. There's on that same website, there's a different pie chart that shows agricultural use versus household use and other uses, and it's about 10 times as much for agriculture. So agriculture is by far the biggest water user across Colorado. But of course, that is what grows our food as well, and so that that's where that water is going from that perspective. But yeah, absolutely, it's a much bigger number for agriculture than it is for like our household use. It's a good question. And that's similarly true, like if you go into the Colorado River Basin as a whole, and that's also part of the kind of crisis in the Colorado River Basin. There's the declines in water, related to drought and a warming climate, but there's also increasing demand for water from water users like farms and communities and so forth.
Awesome. Thank you. That's a great question and a solid answer. And we're going to jump into our Kahoot here, and we've got 25 players. Thank you, everybody, for joining. So our first question here is a place, either natural or artificial, where water is collected and stored for use. What is that known as? And I only gave you 30 seconds to answer here. I'll try and give you a little bit more time on the next question. Oh, we've almost got all of our answers. 3. Perfect. Oh, nice job. Nice job. Almost all of you got this correct. Yeah, 15 out of 25. Awesome. A reservoir is either a natural or artificial place, and sometimes we will call this a lake. So a lake can be a reservoir. A well can be used as a reservoir as well. So somewhere where we're going to store water for later use. All right, we're going to have 30 seconds again for this next question. So are you ready? Here we go. Oh, here's our scoreboard. Here, let's see. Okay, true or false? A natural reservoir that builds up each winter and supplies most of the water from the Western US is called snowpack. True or false? I think You guys got this one super quick. We got all 25 answers right away. Amazing. Yeah, snowpack is the natural reservoir. So as the snow builds up here in Colorado, the snowpack builds in the mountains in the spring when all that snow melts. That's when we'll have some water influxing into the system. Hi, Jay Zola. Thank you so much for joining us. It's awesome to have some Boulder Valley schools with us today. And all right, nice job, everyone. Nice job. All right, we've got few folks looks like almost tied for the winner. We've got one more question here for you. So hot, dry, windy conditions lead to increases in this, sometimes known as atmosphere's thirst for water. What is another name for atmosphere's thirst for water? We've almost got all of our answers. Take a guess. Here we go. Aha, nice. So this one was a little bit of a trick question, and actually I made a mistake here. My apologies. We switched around the location of two of the names, and I forgot to change the correct answer. So evaporative demand is actually the correct answer in this Kahoot, and it looks like 6 out of 25 of you got that right. So awesome. Thanks to you. Good job, you 6 for yeah, good job. So those are our 3 questions from the Kahoot. Let's see. Who is our podium winner here? In 3rd place, Sarah. Nice job, Sarah. In 2nd place, we've got we. And in 1st place, we've got Yo Mom. All right. Thanks, everybody. That was super fun. We're going to take some more questions from the audience here. And I'm going to stop sharing my screen. And so for anybody who has questions, for classrooms that have questions, we would love to hear from you. Please add those into the chat. You can comment directly on YouTube, and we're excited to answer these. So here, let's see. Here's a good question. Where can students find out about plants that are good to plant in natural, climate-resistant landscapes?
Yeah, so my first thought on that would be, it's partly my knowledge being here at CSU, but Colorado State University Extension is a great resource for that. So for one thing, like on CSU Extension website, they have a lot of information already about that. But the great thing too about Extension, there's an Extension office in every county in the state, and so the answer of what to plant in Boulder may be rather different from what you'd want to plant in, in Burlington versus in Grand Junction. And so if you're not kind of finding the answer you're looking for on the website for Extension, then there's an expert in the county that can kind of help out with that. And so that's a really good resource. There are also soil conservation districts in each, maybe not in every county, but in every kind of region of the state, and that's what they are there to encourage as well. And so they try to encourage people to plant plants, whether it's like crops for agriculture or just for your backyard, that are going to be good for that particular area and help help the soils stay good and healthy and not need so much water. It's a great question. I saw there was a question from Randy there about the Colorado River Compact, and so that, yeah, exactly. I mean, that is essentially the story. Of course, there's it's always a little bit more complicated than that, but right, the Colorado River Compact that determines who gets to use how much water in the Colorado River was negotiated in the 1920s, and that was a particularly wet period of time in the Western U.S. The river flows were high. The rivers had a lot of water in there. But kind of the wrinkle to that is there was actually a scientist at the time who kind of said, hey, you all, we know there have been these periods in the past where it's been even drier. and maybe we should account for that in how we allocate the water. But that scientist was kind of ignored, and they decided to go with these numbers that were higher flows that, right, exactly, have only been matched a few times, again, historically. So the amount of water that was allocated is much larger than the amount of water that's actually there most of the time. If you're kind of interested in the details of those negotiations, there's a great book by John Fleck and Eric Kuhn that kind of goes into all those negotiations at the time in the 1920s. To come up with the Colorado River Compact. And then there are also other compacts or agreements between states for the other rivers as well, like the Arkansas River, the Platte River, and so the Rio Grande and so forth. You're muted, Daniela.
Oh, thanks, Russ. For folks in the audience, do we have any more questions for Russ today? And just as a reminder, if you're viewing and would like to be entered in our raffle, go ahead and drop us a comment where you're joining from today. And drop us a question for Russ. We're talking about drought, climate change, and all things related to water here in Colorado and in the Southwest. We're going to give you all just a little bit more time to see if you have any questions. I'd love to hear from Ms. Alvarez's class. If you all have any questions, anything at all here for us, you can ask live. We'll also take questions via email. Feel free to connect with us afterwards. This video is going to be live and on YouTube, so you can continue to use this for other classrooms or revisit any of the content that's been presented today. And again, we'll share the links and resources, including the visualization and some curriculum and outreach opportunities to engage your classroom with some of this work, including Snow School and Splash and monthly webinars from CSU. So Randy had an interesting comment here. I'm going to go ahead and show it on the screen so everybody can see. And he said he finds it interesting that in Colorado, that Colorado is warming more in the summer than in the winter. The global average seen is mostly the opposite, more winter warming than summer. Russ, do you have any thoughts on that?
Yeah, no, agreed. It is kind of different for us here in the middle of the continent. Part of it also matters which time period you're looking at. So like our winters have warmed a lot in the long run, like if comparing back to the early 20th century, but recently the winters have not been warming all that much, whereas the summers have been warming a lot in the last 40 years or so. Part of that too is that, I mean, you can kind of think about this as the natural variability in the winter is way bigger, right? So the difference between a cold winter and a warm winter is huge. Like that could be 8 or 10 degrees, whereas the difference between a cool summer and a hot summer is not very much. It might only be like a couple of degrees on average. So seeing the warming we've seen in the summer, which has been quite large, it's easier to separate out the signal from the noise, so to speak, that the signal of warming in the summer is just a lot easier to pick out because it's so much bigger than the natural variability. Whereas in the winter, we know we can get cold winters, we can get warm winters, everything in between, and that natural variability is a lot larger. And so then the kind of perceiving the warming on top of that is a little bit harder than it is in the summer, if that makes sense.
That's interesting.
And similarly, like here in Colorado, it's our high temperatures that are warming more than our low temperatures, the nighttime lows. Whereas in a lot of other places, it's the opposite. So if you look like in the eastern United States, where you're close to the ocean, or like the southeast, then it's the nighttime lows that are warming a lot more than the daytime highs, because it's kind of adding that moisture. So the more humid it is, the warmer it stays at night. So in those areas where there's a lot of humidity in the air, and then you're adding more humidity to it, the night times warm up, but the daytimes don't warm as much. Whereas here it's the opposite. We're kind of a dry place to begin with, which allows the daytime highs to get a lot hotter, but the nighttime lows are warming, but not by as much. So it is a different kind of regime here in being in the middle of a continent versus being on a coast, for example.
Yeah, thanks so much for those details. All right, we'll take a couple more questions here. If anybody has any other questions to share, while we wait to see if there's any other questions from, yeah. So Mary wants a little bit more information here. Why does that happen? Is it because of the mountains? Does that affect?
Yep, the mountains is part of it. The being a long distance from any of the moisture sources is a big part of it. So, just if you think of Western Colorado naturally is a very dry place, or, much of the Southwest is a dry place, because it's a long way from the oceans. And then also the mountains do tend to be, when the moisture comes in, the precipitation falls in the mountains, and then we end up being kind of in what's called a rain shadow. So places with winds that generally come out of the west, you bring in all this moisture from the ocean, it gets lifted up over the mountains, you get tons of rain and snow, but then that air sinks on the other sides of the mountains, and it ends up being pretty dry. And so these places like in the interior west tend to be quite dry naturally. And then that can kind of be accelerated by, if it's warming, then, you're already super dry, and all that additional energy basically goes into increasing the temperature instead of going to evaporating water, and which would tend to keep things cooler otherwise. And so we do see that in other places, like in the Midwest, where there's plenty of humidity to go around, that that this kind of summer warming effect is not nearly as strong, whereas in the West, where it's dry, than it is. I don't know if that explanation makes sense or not, but that's, yeah, it has to do with the mountains, and just the fact that it's kind of we're a long way from those sources of moisture, like of the oceans.
Great. Yeah, it is quite dry in Colorado. Coming from someone who moves from Austin to Colorado, that definitely feel the impact. And Austin's not right on the coast, but you still get a lot of that moisture in the air coming up from the Gulf of Mexico. All right, we've got 5 minutes left. So in this last few minutes, I'm going to go ahead and run our raffle. Right now I have 5 names entered into this raffle. So I'm going to go ahead and share my screen, and we'll do this live with everybody. So if there's anybody who doesn't see their name on there, or if you're interested in joining the raffle, you're still online, go ahead and drop us a comment, and I'll add your name in. I'll just present my screen here. Okay, this should be everybody. If we have anybody else, I'll give you just one more minute here to enter your name if you'd like to enter in the raffle. I decided to pivot from the people who registered to the people who are joining us today. So we've reduced our raffle entries here to folks who have commented. Nobody else? All right, here we go. So Randy Russell's our winner here in this random raffle selection. Randy, thanks so much. And I will connect with you via email to send you a rain gauge. If there's any other classrooms who are interested in the rain gauge or Kokoras or some of the other outreach opportunities we have to engage with CSU and with series around drought and water or other environmental science topics, we are here as a resource for you all. We have a lot of free resources that we're excited to connect you with. And I'm really excited to connect with you. Definitely send me an email if you're looking for more resources, and I'll drop my email in the comments here so that you all can reach out to us. You can also always reach out to Series Outreach, and we will connect you with Russ or with other experts who are working in the field, collecting and sharing this really important information. Okay, Randy asked us to redraw for a classroom teacher. That's awesome. Thank you, Randy, for redrawing. And so let's see. Let's try one more time here. And I removed your name from the entry list. Martha Alvarez is our winner here. And here I can share my screen so you all see that I'm doing this as a random generator. So that's our high school classroom that joined us today. So Ms. Alvarez, I'll send that to you. I'll connect with you via email for an address and we'll get that sent out to you. Randy, thanks so much for tossing that back into the mix. That's thoughtful of you. So thanks everybody for joining us today. We're going to host another one of these in the spring. We'll start hosting on-demand webinars. So keep an eye out for that. And thanks so much. We hope you have a great rest of your week.